morning everybody. I am Ramesh Babu from AIDS department. Today I am going to take a session of cloud computing. So related to C1 I am going to take a session that is understand cloud computing and NIST reference models are coming under the CO1. So overview of cloud computing, it consists of introduction to cloud computing, history of cloud computing elements, essential characteristics, cloud service models, cloud deployment models, NIST cloud computing reference architecture, ITUT cloud computing reference architecture, then network requirements for cloud computing. So the cloud application consists of scientific applications, healthcare, geoscience and biology, business and consumer applications, CRM and ERP, social networking, media applications and multiplayer online gaming. So now let us see the cloud computing definition. So cloud computing is nothing but on-demand delivery of compute, database, storage, application and other IT resources through a cloud service platform via internet with pay-as-you-go pricing. So normally when you want to perform any computing, we are in need of the compute. Compute means related to processor, RAM and storage, etc. Then database also required to store our information in a structured format. So apart from that, we need an application to run our computing related operation. So finally we are storing into one storage. So these are the related things when you want to perform the computing that can be get on demand on demand delivery is possible through the cloud service provider via the internet, that is a pay as you go pricing concept. The advantage of cloud computing is no capital investment. So normally when you want to set up any network environment, we are in need of a server, client and then storage and the applications. See, when you are using a cloud computing, there is no capital investment. By using one laptop through the internet connectivity, we can get into the cloud service provider environment like AWS, that is Amazon Web Service, Microsoft Azure, Google computing platform, that is a Google Cloud environment. So through that we can perform the various computing operation. Here there is no capital investment, only the operational cost, operational expenditure only. So the only operational cost with pay as you go prices. Next one is flexibility in capacity. So the capacity can be increased suddenly whenever we want to run high rate of computing, that is high performance computing. During that time we need a more memory space, we need more capacity of RAM and hard disk capacity. Apart from that, we need a more processing speed also. At that time we can suddenly expand our requirements and we can perform the computing operation. Next one is speed and agility. So we can get the high speed of computation through the cloud computing, because there will be a pool of storage processes and RAM, like that there will be a plenty of processes available. So we can increase our speed of operation by selecting the multiple processes also. So then next one is users can concentrate more on their core business process with no data center maintenance. So we need not worry about any data center maintenance. So everything maintained by the service provider. The next one is go global in minutes. So normally we can identify throughout the world there will be a data centers. So we can connect any service provider through the particular service provider data centers. By connecting that, we can avail the facilities. that is computing related facilities. See, when you are looking to the cloud computing structure, we can identify various types of activities. So when we are looking into the cloud computing, it consists of deployment models. The deployment models is nothing but a private cloud, public cloud, hybrid cloud and community cloud. So in the deployment models, the private cloud is nothing but it is a on-premises network environment. So through that we can perform the cloud computing operation. That is nothing but open stack. When we are looking about the example, that is open stack and Eucalyptus are the example of private cloud. When we are looking to the public cloud model, so it is off premises of an organization. So we can avail the services through that deployment public deployment models. So one of the examples are AWS and other example are Azure. Then next example is Google. So the next one is a hybrid deployment model. It is a combination of a private and public cloud. So we can get a hybrid cloud through the OpenStack with the AWS environment. The next one is a community cloud. So it is related to particular type of service. So like Salesforce.com, it is nothing but a CRM based, that is a customer relationship management. The Google Suite also related to customer relationship management type of cloud. So through that we can get the community cloud later operation. The next one is when you are looking at the service models, it consists of infrastructure as a service, platform as a service and software as a service. Infrastructure as a service consists of compute, storage and network. And platform as a service consists of runtime engine, database and middleware, deployment models. And software as a service consists of software stack, application and application program interfaces. So we can choose whichever service models need to perform the computing operation. So based on that we can do the different operation. The next one is the stakeholders. When you are looking into the stakeholders, there are different types of stakeholders available in a cloud computing environment. And the first one is the cloud service providers like AWS, then Microsoft Azure and Google. Then consumer, we are the consumer and the end user of the stakeholders. Then partners, the service partners are available to give the service to the consumer. And then intermediate service providers are available, that is nothing but the cloud service brokers. They are intermediate service providers between the cloud service providers and the consumer. Okay, apart from that we can have some features from cloud computing. There is rapid velocity, then scalability, resource pooling, and then disaster recovery and load balancing. See, already we discussed about rapid velocity and scalability. When you are looking into the resource pooling, whenever we need particular resources related to memory, that is storage, related to a processor, related to network, so we can avail instantly the resource from the data centers. So then next one is a disaster recovery. Normally we can have some of the disaster recovery during the lightning and thundering and flood, possible to earthquake, because of earthquake we are possible to get some of the data losses. When we want to avoid such a data losses, let us take one example. One organization may have the office at Vijayawada, but another location is at Delhi. See, when the data of Vijayawada will be replicated at the Delhi office, and the Delhi office data will be replicated at the Vijayawada. So vice versa, the data will be replicated at the different location. Whenever any problem occurs at the Vijayawada, the data can be recovered from the Delhi office. So like that we can manage the disaster recovery concept in an effective manner. Then next one is a load balancing. Whenever the number of requests arriving on a particular server, the server may get full traffic. So due to that such situation, the request will be transferred to the next freely available server. So because of that, the load will be balanced and the operation of such application will be in smooth manner. Then the next component of cloud computing is a technology. Here the technology behind the cloud computing is a virtualization. So the virtualization is nothing but by the help of a single physical set of computing environment, we can perform the multiple virtualized environment. So like virtual machine 1, virtual machine 2, virtual machine 3, up to n number of virtual machines are possible to create in a cloud computing environment. So by the help of virtualized environment, we can avoid the requirement of a physical set of hardware components. Okay. So we can do different types of virtualization. That is nothing but a server virtualization, then client virtualization, storage